Okay, Foundations 11 or FOM 11. Welcome to video number 1. We're talking Arithmetic Sequences series. Some of you may have seen this in grade 10. Otherwise, it's new. It's great. Here we go. This is a color by numbers kind of section because we give you equations to work with, but it's about understanding what it is we're looking at. So let's have a look. Now, before we get to an arithmetic sequence, let's just talk about a sequence in general. A sequence is just a list of terms. So it has a pattern or it doesn't. We're going to look at ones that do have patterns, but like if I were to just write this down, 2, 5, 9, 47. It's a sequence. Now, is there a pattern embedded in there? Maybe, maybe not. Maybe it's incredibly obscure, but that's besides the point. The point is that's all a sequence is. Now, in this case, we're given an algorithm for a sequence. We're saying this a to the power of n sequence is given by n plus 1 over n. So if I wanted the first 4 terms of that sequence, I'm just solving for this. When n equals 1, when n equals 2, when n equals 3, and when n equals 4. So what I do is I take my n equal 1 and I plug it into this equation. Wherever I see n, I put 1. So my first value, my first term becomes 1 plus 1 over 1, which is 2 over 1, which is just 2. So then I do that again, but now I go 2 plus 1 over 2, which gives me 3 over 2. And then I do it again, 3 plus 1 over 3, which is 4 over 3. And then I do it again, 4 plus 1 over 4 equals 5 over 4. So there are my first 4 terms, 2, 1.5, 1 1/3, 1 1/4. So I have created a list that demonstrates that sequence. Now, is it an arithmetic sequence? Is it a geometric sequence? It doesn't really matter. It's a sequence. So look at this next one. I'm going to plug in n equals 1, n equals 2, n equals 3, n equals 4. I'm just going to work it out. So I get 2 times 1 minus 3. Well, that's 2 minus 3, so negative 1. And then I get 2 times 2 minus 3, so that's 4 minus 3, which is 1. And then I get 2 times 3 minus 3, which is 6 minus 3, which is 3. And then 2 times 4 minus 3, which is 5. So there's my sequence in this case. Negative 1, 1, 3, 5. That sequence is given by that algorithm. And now I have one more here. And sure, now I have an exponent, but nothing wild or crazy about exponents. And I'm still just looking for my first 4 terms. So now I have 2 to the 1, 2 to the 2, 2 to the 3, 2 to the 4, and we can simplify that to 2, 4, 8, 16. So this sequence is 2, 4, 8, 16, and it is given by that algorithm there. So that's all it means when saying what is a sequence. So now let's narrow down our definition a little bit. What is an arithmetic sequence? So an arithmetic sequence is a sequence that has a common difference. So it means we have a sequence like 1, 3, 5, 7, because what is the difference between each of those terms? 2, 2, 2. That is what we mean by a common difference. So how do you find a common difference? You just subtract term 2 by term 1, term 3 by term 2, so on and so forth. So let's look at these 2 different sequences on the bottom. Well, what's 5 minus 3 is 2. 7 minus 5 is 2. 9 minus 7 is 2. Okay, we have a common difference because that's the same number, which means it's common, and it is difference because we subtracted. So we have a common difference of 2. So now your difference doesn't have to be positive because in this case, if we go 8 minus 11, what do we get? We get negative 3. If we go 5 minus 8, we get negative 3. If we go 2 minus 5, we get negative 3. So in this case, my common difference is negative 3. So determining a common difference is this d value in the equation that we will be using. And this is why it's going to become color by numbers. So let's look at this in action. Once you know you have a common difference, you can use this arithmetic sequence equation. So find the 12th term of the arithmetic sequence. So we have a sequence here. Here are the first 3 terms. and I want to know the 12th term. So what are we looking for? We're looking for T12, which means if that wasn't n, it means n is 12. Okay, a is my first term. Now you can write A, some people write T1, they're synonymous. Now I know what A is because it's given to me. A is 2. So now I have that piece of information and I have that piece of information. The only other piece I need is my common difference. And again, if I look at that, it's easy enough to discern my common difference is 3. So now I can plug into my equation. The 12th term is equal to 2 plus 12 minus 1 times 3, right? This is my Tn, A, N, D. So now I just simplify that out. The 12th term is equal to 2 plus 12 minus 1 is 11 times 3. So the 12th term is equal to 2 plus 33. The 12th term is equal to 35. So if I worked my way down, wrote that list out, say, what's that, the blunt force method, just write the list over and over again, I would end up, when I'm 12 numbers deep, at the number 35. And that's what we can find out using this equation, is we don't have to do that tedious work of just listing. So let's look at another example. Now in this case, I'm given the first 3 numbers of a sequence, and I'm given a number way down in the sequence. And the thing is this, I want to know where that number exists. So I'm given this Tn value of 439. I just don't know what n is, right? I know it is the nth term, they say, but I don't know what term it is. So that's what we're going to find out. Now again, we know A, right? A is 4. And we know D is 3 in this example. What we don't know is we don't know n. So A is 4, so we'll plug that in. But then we get n minus 1 times D, which is 3. Now here's where we have to do a little bit of algebra. Okay, we want the n alone, and we got to get rid of that 4 first. So I'm going to subtract 4 from here and subtract 4 from here, because that makes that 0. So now I get 435 is equal to, this is 3 times n minus 1, so I'll rewrite it as 3 times n minus 1. It just looks nicer that way. Now to get rid of that 3 is multiplying, so I need to divide by 3. 3 divided by 3 is 1, and divide by 3. So what I end up with now is I end up with 145 equals n minus 1. So then how do I get n by itself? Add 1 to both sides, and I end up with n equals 146. So what it tells me is it tells me that 439 is the 146th term in my list. And you can imagine that would take you a long time to write out. So using the equation and using the algebra makes life so much easier. So let's continue. This is where things get a little bit complicated, because now it's like, okay, I have the 7th term is 78, and I have the 18th term is 45. Well, one, you can see that this term is decreasing, so my D is going to be negative, but we don't know what it is yet. And we want to find A. So here we have too much missing information. We don't know D or A. But what you know is you know that you have term 7 here, and you have term 18 here, right? And we know that this one is 78. We know that this one is 45. And we know that in and amongst that we have 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So we have a whole bunch of terms in between. How many terms do we have in between? We have 11 terms in between, which means we have 11 times the difference, right? Because it's difference to each point. So to get from 7 to 18, I have to add the difference, right? I have to add that difference 11 times, which just means 11 times the difference. So I can use that to determine my difference. And 11 times the difference gives me the difference between my two values. So 45 minus 78 gives me negative 33. So 11 times my difference is a full difference value of negative 33. Divide both sides by 11, and my difference equals negative 3. So now that I have the difference, I can use my equation. But you're thinking, wait a minute, how? Well, you have an nth term and you have n. You can use either one. You can use 7 and 78, or you can use, so you could use 7 for n and 78 for tn, or you could use 18 for n and 45 for tn. You'll end up in the same spot. So I'm going to use 7 and 78. So tn equals a plus n minus 1 times d, and I'm going to use the 7th term, 78, is equal to a plus 7 minus 1 times negative 3. And now I work out to solve for a. So 78 equals a plus 6 times negative 3. Switch to white. 78 equals a minus 18, because that's a positive times a negative. And then add 18 to both sides. A equals 96. So I have found my first term. Now, a little bit trickier there, so maybe watch that again. Look at the notes as well. There's a good example for that. So let's look at one more that gets even more confusing. Now, here you have 3 consecutive terms in a sequence. So what we have is we have 3x plus 2, which represents a number. And then we have 2x minus 3, which represents a number. And we have 2 minus 4x, which represents a number. The thing is since we don't know x, we don't know what that number actually is. And that is what we're going to try and find out. And we can find that out by looking at the common difference, because it's still going to be this term minus this term is d. So what we know is we know that 2x minus 3 minus 3x plus 2 is equal to my common difference. Now, do I know what that common difference is? No, but that's enough. I also know that my third term minus my second term will also give me the common difference. And the common difference is the same. Now, here's the beauty. If d equals d, we can set what they're equal to each other. What do I mean by that? Well, if 1 plus 3 equals 4, and 2 plus 2 equals 4, then 1 plus 3 equals 2 plus 2. It just makes sense. So what I can do is I can take this 2x minus 3 minus 3x plus 2 and set it equal to 2 minus 4x minus 2x minus 3, because both of those statements are equal to the difference. And now what I do is I do some lovely algebra. So I'm going to subtract, subtract, and subtract, subtract. So now I have 2x minus 3 minus 3x minus 2 equals 2 minus 4x minus 2x plus 3. Group my like terms on the individual sides of the equation. So this side simplifies to negative x minus 5. This side simplifies to negative 6x plus 5. So what I'm going to do with that is I'm going to isolate. I'm going to get all my x's on one side and my non-x's on the other. So I'm going to add 6x here. I'm going to add 6x here. So that's going to give me 5x minus 5 equals 5. And then I'm going to add 5 to get rid of that. And now I have 5x equals 10. Divide both sides by 5. What do you get? X equals 2. So what I've done is I've solved for an x value that will guarantee that those 3 terms are consecutive in an arithmetic sequence. So I'm going to erase some of this room at the top, and I'm going to plug that value in for x and show you what happens. So we're saying x is 2, which means I have 3 times 2 plus 2. That's my first term right here. Okay, so that gives me 8. And then I have 2 times 2 minus 3, which gives me 4, gives me 1. And then I have 2 minus 4 times 2, which is 2 minus 8, which gives me -6. So it means I have these 3 consecutive terms. And if you look at that, what's my common difference? -7. So boom, it works. We did it. It's all good. So let's now look at the next step, which is an arithmetic series. So what we do with an arithmetic series is we add up the sequence. So instead of separating our series by commas, we separate our series by addition symbols. And what we do there is we are then adding up the entire sequence of values, and we are just adding it up in a relatively interesting manner. And I got a little story for the first one. So if you look at the first example says we are going to sum up the numbers from 1 to 50 inclusively. So what that means is we have a list that looks like this: 1 plus 2 plus 3 plus 4 plus da 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 plus 47 plus 48 plus 49 plus 50. So we're adding all those things up. Now you're given 2 different equations here. You have this one here, and you have this one here. The difference between the two is that this one, you know the last term. And this is actually quite the, I don't know if it's an urban legend at this point or if it's actually true. I'm going to go with the fact that it's true. But there's a famous mathematician named Gauss. And the story goes that when he was a kid, he was in class with his teacher. And this is a long, long time ago. So teachers were a little bit more stern and they went right to the minute. And this teacher was like, I'm going to give these kids an assignment that's going to take them 15 minutes because we got time to kill. And it was this similar question. It was, I want you to add up all the digits from 1 to 100. And what Gauss did was he basically put his hand up right away and said, oh, done. So how did he do it so quickly? Well, he identified this pretty wicked pattern. If you take the first number and you add it to the last number, you get 51 in this case. If you do that again, and this only works when they're consecutive. That's not true at all. This works when you have a pattern. You again get 51. 3 plus 48 is 51. So you get the same thing over and over again. You get that same number. So what he noticed was you take your list, you cut it directly in half, and you multiply that by the sum of the first and last digit, which is what this is saying, right? It's saying n divided by 2, the number of terms divided by 2, times my first term plus my last term. Wow, wow, wow. Isn't that amazing? So if you know the last term, use that equation. And in this case, we do. We have 50 numbers, so the sum of 50 numbers is equal to 50 over 2 times 1 plus 50. So the sum of the first 50 numbers is equal to 25 times 51. So the sum of the first 50 numbers is 1,275. Lovely, wonderful, great. So if you have the last digit, if you have the last number and the first number and you know n, use it. It's way easier. But obviously, I have other examples for us. So here we have an arithmetic series. It says find the sum of the first 25 terms. So what does that give us? That gives us n. N is 25. Looking at our series, we can see we have a common difference, d, of 4. We can see that we have the a value of 11. We don't know L, so we can't use this one. We're going to use this one. Now you could find L, but let's not worry about it. So the sum of 25 terms is equal to 25 over 2 times 2 times 11 plus 25 for n minus 1 times 4. And now we just got a whole bunch of arithmetic here. 25 divided by 2, 12.5. And yes, decimals are fine, 12 and a half, okay? Where do we go from there? Well, 2 times 11 is 22. And then 25 minus 1 is 24. 24 times 4 is 96. So we end up 22 plus 96. So 12.5 times 22 plus 96. You want to add those together first, and we end up with calculator work 1,475. So depending on the information you have, you can narrow down to either this equation or this equation. So find the sum of the series below. Okay, now looking at this, you're probably like, yes, I got my L term, it's 100. Yes, I got my A value, it's 7. Oh no, I don't know how many terms there are. So there you go, bit of a pause. If you don't know how many terms you are, the summing value is not going to help. We come back to our good old-fashioned sequence value. Because in this equation, we can solve for n, because what do we have? Yes, this is L, but this is also my nth term. It's my last term. It gives me how many terms there are in my series. So I have 100 equals, I know my A value, I know that n is what, and I know that my d in this case is 3. So now, again, algebra, subtract 7 on both sides. You get 93 equals 3 times n minus 1. Divide both sides by 3. You get 31 equals n minus 1, so that means, boom, n is 32. So you solve for n first. But then from there, yes, you can use that equation. So now I know that the sum of 32 terms is equal to 32 over 2 times 7 plus 100, because I have AL. This makes life easy. So I get 16 times 107, which gives me 1,712. So yeah, you got to come back to your old sequence equation to solve for n, but then you can plug it in. So it's sort of a two-piece question. So we'll do one more of those. Similar scenario. Yep, I got my A value here, I got my L value here, but I don't know n. So again, I'm going to use Tn equals A plus n minus 1 times d. So in this case, my nth term is 137, my A is 5, my n I don't know, and my d in this case is 4. So now subtract 5 on both sides. 132 equals 4 times n minus 1. Divide everything by 4. And what do you get in this scenario? Well, 132 divided by 4 is 4 goes into 13 3 times with 1 remainder. 33 equals n minus 1, so n equals 34. So we got our n, and now we can use our summing the first 4 equations, or 34, sorry, values. Is 34 over 2 times 5 plus 137. Which gives us 17 times 142, which then we calculate out to 2,414. Boom, boom, boom. So that is sequence and series. There's lots of practice in this section for you to try. The next 3 sections are very conversationally intuitive. We're going to talk about patterns and puzzles and deductive reasoning. So the videos will be probably just working through some of the examples, but nothing overly in depth, because there isn't really an algorithm that I can teach you for this. A lot of this is just using that old brain and trying to think your way through to identify patterns. It is the logic and reasoning portion of mathematics that we take for granted due to the internet and instant gratification. Yes, I realize you're watching these videos on the internet, so don't worry, I don't hate it. But it is good to be able to think and work our way through as well. Thanks so much. See you next time.